now have a problem to solve. Now we have a complex problem to resolve, but it seems complex anyway, but very, very simple to solve. We have two diagrams, diagram 1 and diagram number 2. We only asked to calculate the internal resistance. If these two diagrams or this circuit are connected together, what is the internal resistance of the circuits? That is what the question is all about. Calculate the internal resistance R in the diagrams given below. So you only expected to calculate the internal resistance, nothing more. What do? Very simple. State the Ohm's law, which is given as I is equal to E all over I plus small r. Once this is done, you've started well. The next thing to do is to equate. Substitute where necessary and equate, then simplify. So the first one, let's substitute here, first diagram. We have capital R. We are looking for this, and the current is given as 0.8. This is 0.8. All right, so what do? Very simple. We have, for this I is equal to E all over R plus small r. So we have current 0.8, 0.8. Okay? Then we retain our E because E is not given. We retain it. Good. Then the next thing we substitute for capital R is given as 2. So we have capital R is 2. Alright? Small r is not given. That's internal resistance. It's not given. So we have 2 plus small r, the internal resistance. We call this equation number 1. Equation number 2 has to do with second diagram, where we have the external resistance as 5 ohms. Internal resistance is not given. Current is given as 0.4 amps. So we start again in number 2. 0.4 is equal to E all over the capital R, which is the external resistance, is given as 5 plus small resistance, which is R, not given. That's what we are looking for. And this is equation number 2. Alright, we are going to divide equation number 1 using equation number 2. Okay? And if we do that, see what will happen. We have equation number 1. We start with 0.8 is equal to E all over 2 plus R all over 0.4, right, is equal to what again? E. E all over 5 plus R. We have done the first thing, analyzing the question, and now we are dividing. Okay? So what do? Simple multiplication, simple division gives that 0.8 all over 0.4 is equal to, because this we cancel this. And now we have 5 plus R all over 2 plus R. Alright? That's very simple. The next thing we are going to do here is simple cross multiplication. Once we do that, our answer will appear. And we have this we move to this point, and then this we move to that point. It becomes 0.8, bracket open, 2 plus R, okay? And then 0.4 we move to that point, it becomes 0.4, bracket open, 5 plus R. That's all. By the time we are done solving this, if we simplify further and collect like terms, our answer is going to be R is equal to 1 ohms. Okay? That's the internal resistance. Can you see? The internal resistance R is 1 ohm. What does this mean? It means the amount of opposition that this internal resistance offer in this circuit is just 1 ohm. This 1 ohm is capable of reducing the current from being full. That's the essence. Once we understand this and we account for it, remember we will also take note of the fact that the internal resistance, the potential difference across the internal resistance is the lost voltage. And that is why the terminal potential difference across the external resistances is always less than the EMF, the energy of the circuit. I repeat, if we find out the lost voltage here, the lost voltage or the lost potential difference across the internal resistance of a cell, it accounts for the reason why the terminal potential difference across the external resistance is less than in value than the electromotive force E of the cell. That's the reason. So with this, if we're given a question like this is how to resolve it. At times it can come. It can come this way, and if you're not well grounded, you might be thrown off balance. But once it comes this way, try to equate. Try to remember that there is a particular formula, Ohm's law, that you need to apply, and that is this. Define it for equation for diagram number 1. Also define it for diagram number 2. That's this. So this diagram has this. After which, divide equation number 1 with this. Further simplification yield than all this, and then finally the answer, which is 1 ohm. So the internal resistance of these two circuits, when combined, is just 1 ohm. Alright, that's it. If any of the steps are not clear, of course, put it in the comment section. I am signing up now. See you in my next lesson.